Hello everyone. So again, we are back with the daily lead code practice questions. So let's start with the first problem, middle of the linked list. So this is one of the easy problem that we will be solving today. So the question is pretty much clear and simple. We are given with a singly linked list, and we have to return the middle node of the linked list. Let's say if we have two middle nodes, then we have to return the second middle node. So let's say for an example, we have a, a linked list, and if this linked list, if the number of nodes are odd, then we are returning just one middle node, that's three. And if we have like even number of nodes, then we are returning the second middle element, that is four over here. So the question is pretty much clear and simple. I guess everybody got the gist of the question. So do you have any questions regarding the problem statement? Anyone? Yeah. So I think the question is pretty much clear. And so can we discuss the approaches that we have, like different approaches? Anyone who wants to come up with his or her own approach?
Hi, so Tanmay this side.
Yeah. Hello, Tanmay.
So what I did in this question was just a simple approach that I traversed the linked list, and I had three parameters. I had one uh, middle node, one boolean flag, and a temp node. So actually, temp node was equivalent to head node. What I did was I kept my boolean false, and then when my boolean was false, I moved both mid and the temp node forward, and then I made my boolean true. And if in case my boolean was true, I moved only the temp node forward. This way, every time I encountered an odd node, like when the size of my linked list was odd, so at that point of time, I was my mid element was every time at the middle node, and when the size was even, then at that time my middle element was at every time at the right position. So basically, I traversed till array dot length is not equal to null. मतलब linked list connects is not equal to null, and I got the answer.
Yeah, I also did in the same way. Like I had a temporary pointer, and then I just used a counter variable, and if the counter variable was odd, then I just incremented the mid by one and moved the pointer by one. And if it was even, then I just did nothing, and I just incremented the count value, and I moved the head pointer one step further. So anyone?
Okay. I would like to like give a suggestion.
Yeah.
You're using count mod 2 not equal to 1, right?
Yeah.
मतलब whenever like we have to divide every time, like always try and use the bit
Yeah.
manipulations.
Yeah. 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 I know that,
Yeah.
but I generally prefer this because it's more understandable than that. Just for my purpose, I do that.
Okay.
So can you tell me how the bitwise is more efficiently? Is it just for
Uh,
or faster purpose or
it's much more faster than the
okay?
modular sign and divide sign.
Okay. Okay.
Like I posted a simple, it was a simple question. I just used bit manipulations on lead code only. So my answer was 2 milliseconds faster than 100% of the Java submissions.
Okay. I
And
will
the
make
question
sure
was
that I
like,
will use bitwise operators.
yeah, that's
Okay. So, are there any other approaches like we can discuss for this
Yeah,
question?
so one approach which I followed is to use just two for pointers. every time the loop runs, or you just take one of the pointer which will run two steps and one pointer which will take one step. So the concept of fast and a slow runner. So where at every step you will run the slow pointer as just a single step because it's half, and the fast pointer will run the two steps. And at the end, what will happen when you are crossing the boundary of the linked list, your slow runner will automatically be at the middle position.
Yeah, fine. I guess it's much more faster than our
So,
approach because
Ashish, I
yeah,
have
it will
posted
take
the link
n
to
by
the code
two.
if you mind opening
I
it
have a doubt.
from the lead code, from the Slack.
Yeah, sure.
I have a doubt. What if the size of linked list is just one or two?
Yeah, if it's one, I guess.
No, no,
Yeah,
no,
the
no, no.
constraint
Not
is
in the
between one
question.
and one.
Not in the question. Not in the question. In the approach that our fast pointer is moving two
Yeah,
steps
I
ahead.
guess for two it will work because if we are in starting from zero, then if we just move the slow pointer one and then we move the other pointer by two, then I guess we reach the end of the linked list. So we will be pointing to the middle of the element.
Hey, Ashish.
Uh, yeah, hello. Yeah,
Okay, there could be a case. It's not
Hello.
here, but hello.
yes, please go ahead.
Okay. What if the linked list is empty? Well, it's no. It's generally not a case, but in Hakarang, most of the question it has a case in wherein the
Yeah,
linked list is
for this, I
empty.
guess it is mentioned one in hundred. Like number of nodes
Yeah,
is
yeah, yeah.
from one
Okay,
to
okay,
100.
okay, okay, okay. Cool.
I mean, for both, for any of the solution, right? If linked list is empty, that also should work, right? For fast and slow pointer, also it should work.
Yeah, it will work. So I guess the slow and fast pointer concept is much more good than the counter variable concept because we can solve it just in n by two time complexity. So do you have any other approaches? Anybody?
I mean, there is. I think these are all the very efficient approach. Inefficient is like put everything in the another data structure and then get the middle, and those are not anyway efficient.
Yeah, but if we will add like push into some array and all, then we can't return the node, I guess. But we can just return the value part of
In
the
this
node.
case, we'll basically we'll have a node pointer in that whatever
Okay,
data structure. It's not data. Copying data
okay.
is not a good solution, but I think those are not any yeah good solution. So this whatever we have discussed, that is good enough. One thing to add is that the uh, fast and slow pointer is that technique is useful, because if somebody tweak the question and say that, return me the fifth from the end, or written those kind of question, if the question is tricked a little bit, that all can be solved with the fast and slow pointer,
Yeah, sure.
right? Yeah.
Yeah.
One
So
of the
do we, yeah.
sorry, one of the variant in this question which I was thinking was around if there's an even number of elements and you want to return the first of the middle ones. Right now, in this case, we are saying if there are two
Yeah, yeah,
middle
yeah, I
ones, then
got you.
return the second one.
Yeah, that would be a nice question. Sure.
We'll use the fast and slow approach only, and we just have to keep a previous node, right? Wherein I'll return the previous of my slower node as the output every time.
But for that, I guess it won't work for the odd number of nodes. Like if you will return the previous one.
No, for the fast and slow pointer, I think then the case will be uh, before you increment the slow pointer, you have to first ensure that the entire fast counter is complete. Like if you have five elements and your fast pointer is not able to complete its two log hoops, then you just don't upgrade the slow pointer. So for the first one, you have to, if you are trying to find the second middle, then you can first increment the slow pointer and then go with the fast pointer, even if it's not able to complete the 2 steps. But if you want to find the first one, then probably you might want to first check whether the both fast pointer, 2 steps for fast pointer are available. If they're available, fine. If not, then don't increment the slow pointer.
Rather than
Probably that
checking
will.
this much amount of stuff, just keep a Boolean operator like
Mhm.
I did. Just keep a flag which gives me true when I'm at the even junction and gives me false when I'm at the odd junction. It's fairly simple. I'll check it out that if it's even, then if it's true, then I'll have to return the mid, and if it's false, then I have to return the mid minus one.
Yeah, that would work.
Linked list, how will you go back? Mid
Keeping
minus one.
a previous node, right? I already
Yeah,
told
we will
you.
use a
Okay, so
auxiliary
yeah, that's fine.
node. Yeah.
Okay, cool.
Sure. So shall we move to the next question?
Yeah.
So I guess a question similar to this was discussed in the one of the recent session, I guess. So on that we had to just simply calculate the Hamming distance between two numbers only. That's it. But for now we have to calculate the Hamming distance for a complete array, and the condition is like we have constants with 10 to the power 4. So uh, a basic brute force, I guess, won't work because I tried that and it gave me a TLE for that. So I think the question is pretty much clear. And if anybody has a doubt about Hamming distance and all, then please. Any questions regarding the problem statement? Okay. So um, anyone tried solving this or want to tell his or her approach, then please go ahead. Okay, fine. So,
I think
okay, please go ahead.
I was just saying, I think the solution is pretty much what you have written is, just for each bit position, find out how many, ones and zeros are there. And then how many pairs can you create? Because each pair will contribute to one Hamming distance. Let's, just take one bit position at a time, because anyway, the Hamming distance will be sum of all the differences in bit positions. And then
Yeah, yeah.
for each bit position, let's find out how many pairs of zeros and ones we can create, which essentially will be if you take the bit position for all the array elements and just find out number of ones, how many number of ones will be there for all each of the element in that bit position, and then the remaining ones will definitely be zero. And just creating a
Yeah.
combination of zeros and ones will be the multiplication of the, if there are 4 ones and then 2 zeros, then you can create 4 into 2 8 combinations of zeros and ones.
Yeah, I did the same way. Like I just
Yeah.
checked whether the I tried like every number has a 32-bit fixed, and I just checked whether the each beat is 1 or 0, and just uh, multiplied the number of ones and the number of zeros. So
Right.
yeah, it's just,
So
so
right now what you have done is for 32-bit number, it can easily be extended to a 64 or a 128-bit number.
yeah, but the range of the integer was like 10 to the power 9, so I thought it should be
Right,
only
that should be.
the
I'm just saying if we want to extend it to the same approach will work for the 64-bit and 128-bit also.
yeah. Any other approach? Okay, fine. So we're moving to the next question. So I guess this question is pretty common in various interviews, and it is normally in almost every website and like HackerRank, Hacker everywhere. So just have to find the median of two sorted arrays, and the sizes of the two sorted arrays are different, maybe different. So for it's just simple, like if we have 1, 3, and 2, then the number of total number of elements are odd. So we are just returning the two, and if it's even, then we are returning the median of the two middle elements, like 2 and 3. So we are 2 plus 3 by 2. So there we go. So anyone tried solving this question? Like it's pretty much clear. The question is pretty much clear, I guess.
Hi, this is Vipul. So what I have done that I have
Can you
merged.
can you be a little loud?
Yeah, it is audible.
Yeah, but can you be just a bit loud?
Okay, now.
Yeah, fine.
Okay, what I have done, I have merged these two arrays into one, and if I merge these two arrays into one, it's easier to find median. Like I can find the middle element for odd length, and for even I can add the uh, this take the floor and seal value and find the median of that.
Yeah, it will work, but the condition, it is already mentioned that we have to do it in the log m plus n time complexity. So the way that you are suggesting, it will take m plus n, I guess. So it's not an efficient way to solve that problem.
Okay.
Anyone else who want to contribute for this problem?
Hey, Tanmay this side.
Yeah, hi.
I kind of know the solution to this problem, though I haven't coded it yet. Matlab, I'm not
Yeah,
100.
same from my side. I know like a gist of the solution, but I haven't coded it.
Yeah, the solution
Yeah,
works in the complexity order of log of minimum of m comma n.
yeah.
Yeah, we have to like do binary search on both the arrays, find the middle element and the array like which is having the greater middle element. We'll have to do the binary search on the right side and just go on doing it unless we get a position wherein my left, matlab, my smaller elements left is greater than the arrays right, and same for the other two. And then we check for the condition of the length. I guess that's how it's done.
Yeah, similar to that only. Like I have seen some many problems like that. We have a 2D matrix, and then each row is sorted, and we have to get the middle element. It's somewhat like that, but we have just two different arrays of different sizes. So what I think is like there can be one way we can get the minimum of the first element only, like 1 and 3 the minimum will be 1, and the 2 and 4 the maximum will be 4. So our search space will be between 1 and 4 only, like our answers should lie between 1 and 4 every time, and we can just use divide and conquer uh, and reach to a solution. So it's basically a question from binary search only.
The approach I know is we apply binary search on the above element. Like I divide 1 and 2 into two arrays, and I divide 3 and 4 into different arrays. Now I'll
Like we're
check
partitioning the two.
both the
Okay,
arrays. Now
yeah.
I'll check 1 and 4, and I'll check 3 and 2. As I know
Okay.
that 1 is smaller than 4 and 2 is smaller than 3, I know that I have arrived at a solution wherein my above array is less than, like, when I know that what the condition I want is both the left hand side of num1 and num2 should be smaller than the right hand sides of num1 and num2, as in considering the whole as a single array, as in 1 comma 3 should be smaller than 2 comma 4.
Yeah.
but that's not true in this case. So what I'll do is I'll like move to the right or I'll move to the left for the 3, 4 array. I'll call the binary search on the left hand side. Now what I'll do is once I call this, I'm at a position wherein 1 and 2 will be on the left hand side and 3 and 4 will be on the right hand side. Now I'll check the condition for the same thing, and now I know that 2 is less than 3 and the other twos are zeros, so I need not check for them, and herein I get the answer. I have a video, if you'll say, I'll share it on the Slack platform.
Yeah, yeah, please do share that. I also found a
So,
video of Tushar. I saw that uh, long back. So it was a nice video of him.
yeah, I don't know, Tanmay, if my approach is similar to what you are saying, but what I did was instead of looking at the numbers, so what I did was I know there are total of m plus n elements, like 5, suppose in this case 4, and what I do was just take one of the arrays and do a binary search of elements, like suppose in that case 1 and 2. Let's take 1 as example, and then what I'm doing is trying to find how many elements in the num2, again by using a binary search, are less than that number, less than or equal to that number, and then using that total number of elements and seeing if that is the number of elements that I require to reach to a median. So median is nothing but the number of elements on left hand side and right hand side should be equal if we sort it
Yeah,
in
yeah,
the
yeah.
order.
Your approach is, yeah, that's what I said. But you'll have to check the condition, na, ki what if in case I'll give you an array 1, 2, 3, 4, 7, 8, 9, and 4, 4.5, 5.5, 6, and 7.5, 8.5, 3, something like this. A bigger
So both
array.
of the arrays are sorted, right?
Yeah, both of the arrays are
So,
sorted.
right.
So you'll have to like in any case you'll have to reach a position wherein your left hand side has 7 elements and your right hand side has 7 elements. In case of if total
Correct.
number of elements are 14, right? So
Correct.
for the first case, when you apply a binary search, you'll be at a position wherein your left hand side has is having 7 elements, but it's not
Mm-hmm.
the truth case wherein like it could be like you're having 1, 2, 5, 7, and something like this, and on the
Right.
other
So
side
I
you'll have,
understood the case
yeah.
you're saying. So from the first array, we are just trying to find a point after which we'll get more number of elements on the left hand side. We just have to find that borderline. So suppose I have 1, 2, 5, and 7, and if I choose 2, I'm getting suppose 4 elements, which is less than the median. And if I choose 5, it is more than the median. Then I know definitely from the first array, I cannot choose 5 to be part of my, in the median boundary. So what I do on the first array, I'll just choose the first 2. And I'm for sure, because of the, if I say fifth is added and it's not getting summed up, all the remaining elements will be part of the second one. So I can just take, 2 elements from the first and the remaining, whatever is required for the median from the second element. Now, to find out what is the actual median, you just have to take the edges of the both arrays. Like from the first, you find 2, and from the other array, you find suppose 3. The second and third, and try to find what is the maximum. So that will become your median in case of odd, and the average of top 2 maximum if in case of even. The
Yeah,
only concern that I have in this problem, which I just mentioned, is I'm still not sure how it is O of log of m plus n. What approach we are discussing will become log of m into log of n.
true.
So if you say if you open the, Ashish, could you
Yeah.
open the link from the Slack? I
Oh,
posted the solution a
okay.
few minutes back. I can repost the link.
Yeah, please repost that.
I posted in the chat window. If you can just open that.
Yeah.
Yeah, so if you see the first while loop, which is in the main function, this will run O of log m times. one of the arrays, and every time in that I am calling this number of elements less than equal, which is at the bottom, it's again going to run log of m. So it's essentially log of m into log of n. I'm still wondering if there's a solution which will do it in log of m plus n.
So this both array are sorted, right? Num1 and num2.
Yeah, yeah.
Yes.
So, and we have to find a median. So
Yeah.
Right.
can we try merging both array?
Yeah, but mm, uh, yeah, it's
So when we reach at the point where we know that this is the because we know size beforehand. So
yeah,
Yeah, we know.
in that case, it is just simple traversal of the both element till we reach the middle, and then return the median. We don't have to store everything also.
But then it will be log of m or n, m plus n or m plus n by 2.
Wait,
But
if
sorry, I'm just one. Sorry.
yeah, go ahead.
It will be order of m plus n by 2. That's the complexity if we combine those and then just traverse and see where we are, finding the number of elements.
Yes.
The
Excuse me.
the
Yeah.
required complexity is log of m plus n.
Ashish, could you open the question?
yeah.
Not this one.
Oh, sorry.
The median one.
Open
Again.
the discuss platform and then
Sorted array.
most votes. Not this one. Tag on most votes. The first thing that will get is this is the solution having of log of minimum of m comma n, and it's also having a video that explains it really well. Just swipe it up so a bit more. This is not the solution. This is the solution, and below is the video.
Yeah, I was mentioning about this video only.
Yeah, same here.
Yeah. And there is a good article on Gigs for Gigs about this question only.
So,
Yeah.
so we need to come up with only log m plus n. We can't
Yeah,
do better.
We can.
we
The
can do
best
better, but
the best complexity is log of minimum of m comma n.
Oh, log. I see. Okay, I got it. So yeah. Okay, my bad. So m plus n is log of m plus n is better than m plus n. Okay. Yeah.
I have not looked at this solution, but probably I don't know. I'll have to check. The best I could reach out to was log of n into log of m.
Okay.
can't we do like this? Like if we got the minimum and maximum element like 1 and 4, then we will do just 1 plus 4 by 2, and we will loop
But then,
like
yeah,
how
I
many elements
understood
are
what you're
less.
saying. But
Yeah.
then it will not be m plus n. It will be the minimum values in array and the maximum values in array. Log of minimum value plus maximum value, which may not be essentially same as m and n. M and n are sizes actually. We can have a num1 starting from minus infinity or minus minimum value of the integer to maximum value of integer. Then it will not be log of m plus n.
Yeah, I got it.
Is that what the video says? I have not seen it, so I
No,
cannot
the
comment on
video
that.
is different. Like the video is okay.
Only in case we basically look at the middle of the one array and then discard one half of that, right? Then only we can get that.
Mhm.
I'll have to see. I'm not sure what it is doing. Instead of values, it is working with indexes.
It's not log m plus n is log m into log n?
Not sure what it is doing. I'm not seeing this solution. I'm just looking at it for the first time.
Rather than seeing the solution, it's better to watch the video, I guess.
And that we can, I think, do after,
Yeah, yeah.
if anyone else has any other solution or any other way. Not, then probably Ashish, we can wind up the call. If we don't have anything else to discuss.
I had a doubt if you could like help me out.
Yeah, good.
And posting the question on the chat platform.
Yeah.
Hello.
Yeah.
Yeah. This was the question, right, Tanmay?
Yeah, this was the question.
So, would you like to share your screen and please brief us with the question?
Ashish, you'll have to stop sharing your screen for me to share it.
Okay. Okay. Sure. Yeah, please.
Okay, so the question says that we have a 2 by 2 matrix and we need to sort it diagonally, as in you can see these arrows. For example, let's consider this one, 3 2 1 1. So for the answer, we'll have to like make it such as 1 2 3. Similarly, for this case, diagonally it goes 2 1. So in the answer we need it 1 comma 2. And similarly 1, 2, 3, 1, 2, and 1. We'll have to sort it this way, diagonally. I was able to like manage getting answers for most of the cases, but I failed for a single case. I'll share that case with you too. Mm, okay.
Are you getting a TLE or is it?
I'm just failing for a single test case.
No, are you getting error like timeout or is it you're not getting the correct output?
I'm not getting the correct output.
Okay.
This is the case I'm failing for. I don't know. They said that it's gonna be m cross n array, and this is not an m cross n matrix.
Uh, Hey Tanmay, could you just go with your logic and just tell so that we'll know where your logic has gone wrong if it is your logic error?
Okay.
Is it a sort of brute force method?
Yeah, it's a sort of brute force method. What I did was I just iterated over these points. I created an array and just sorted it and returned it to my answer.
So it should be n square log n then.
It's
Suppose n, it will be n square log n.
yeah, it's n square log n. nm log n actually.
Actually, it
N
will
log
be
n.
n cube. If we consider n cross n, it will be n cube log n
No, no, no.
because
Like,
you will have n square diagonals or n square lines, and for each array it will take average of n log n for sorting.
yeah, sure, sure. Yeah, correct.
Yeah, you could also use the heap sort method. It's n square log n.
No, you have sorry, heap sort log n. So it will heap sort is again n log
The
n
same.
n
Yeah,
Yeah,
proportion,
yeah, yeah.
heap
right?
sort is n log n, but while we are adding to the heap, it gives me the output, right? It's just adding
Correct.
and
But
removal.
there are n square diagonals.
Yeah,
Yeah,
correct.
so for every diagonal, I'm iterating on all n square elements, right? And while iterating, I'm sorting them. I'm not iterating any element twice. And at a single iteration, I'm able to sort them. So it's n square log n, if you get me.
Sorry, I'm still not able to understand. So what you're doing is essentially taking all the elements and sorting them out
All the
in the
diagonal
single iteration.
elements?
Yeah.
No.
So in the
Let me share my whiteboard. Okay. So what I'm doing is like this is my 2 by 2 array.
Mhm.
I'm sorry, I'm not having a stick. Okay, so I'm actually iterating on this
Mhm.
and sorting this. Then I'll iterate on this. I'll
Right.
sort this. I'll iterate on this. I'll sort this. I'll do the same for this and similarly for this and this.
Correct. So you will
So
do this
that,
activity n square times,
yeah, correct.
Yeah,
So it
and
will be
each
n
of the
square n log n. Yeah. So it will be n cube
yeah.
log n.
It can also be done in n square login. I'll show you how. Like I have 3 in my heap right now. Okay, I'm having diagonal that is 3, 2, and 1. I go on 3 and I add 3 to my heap. Then I'll go to 2. I'll add 2 to my heap and then I'll call up pp5. It will be like this. Then I'll go to
right.
1. I'll add 1 and it will call up pp5. It's like
Correct.
1, 2, and 3. That's how my heap's gonna be. So I'll get an
Right.
output that's 1, then I'll get an output that's 2, and then I'll get an output that's 3. So I'm not
And
iterating on 1, 2, 3 more than once.
no, no. What I'm saying is this log n function of heapification that will be called how many times? Like you are first taking one, it will create an element
Just
n.
like, wait, consider this to be my diagonal array. Okay, 3, 2, 1. Okay, and then let's have 2, 1, 0, 1, 0, 2, somewhat like this. Okay, so what I do is I'll for now I'll iterating on this thing. Got it?
The
So
longest diagonal, right?
yeah, for now just consider a single diagonal. So I get to 3. I add it to my heap. I have 3. Now I get to 2. I add it to my heap. Now I am having 2. Now I get to 1. I add it to my heap. I'll have my final heap will be like this, right? 1, 2, and 3. Okay, calling up pp5 and doing its function inside it. So now I just iterated on these ones and I'm having the minimum element. Now what I'll do is while returning this array, I'll just put this one out. I have 1 at this place, then 2 at this place, and 3 at this place. I'm not iterating twice. I'm just iterating a single time and doing n log n operation.
So
You
this
get
n log n will be done for how many?
for all and I'm not do
Exactly. Like how many diagonals are there? It will be n squared diagonals here.
n square diagonals, but this is not n log n then, right? This is just log n if I'm not wrong.
No, so
It's
heap
not like
sort.
that.
So what you're
What?
saying, you're not iterating it over second time. You are correct. You're not
Yeah,
iterating it second time, but the first time you're inserting it into the heap, you're taking all the elements one by one, and every time you insert an element, a log n operation is performed. And the
okay,
maximum number of elements in a diagonal will also be n,
okay.
right? So that overall complexity for sorting a diagonal using heap sort will also be n log n. So if you go to the smallest diagonal, it will be one log one, then 2 elements, 2 log 2, and then this way, the longest diagonal will be n log
Yeah,
n.
2 elements will be 2 log 2 and 3 elements will be 3 log 2. So I'm just going over n square elements. So it will be n square log n. That's what I'm saying. I may be wrong.
No, I'm talking about the single. Let's take on just a single diagonal, the 3, 2, 1. Okay, so you're saying it's a 3 cross 3 element, 3 cross 3 matrix. Let's assume it's a n element, n cross n element. How many elements do you think will be on the diagonal?
N cross n. N.
N, correct. So if you take each of that element and try to insert it into a heap, every time you're taking one element and inserting it into a heap, you're getting n log n complexity for that diagonal. Is that correct?
Yeah.
Right. And how many total diagonals are there?
N square.
So n square, and let's take the worst case, n square will be, one time it will be 1 log n, 2 log n, 3 log n, 4 log n, and just assume ignore the numbers from log n. It will be 1 plus 2 plus 3 plus 4 plus till n, and one summation of 1 till n is n into n plus 1 by 2, right? Which is n square.
Yeah. Okay. I got it.
So because of the log element, it is taking up, yeah. So I hope you understand that.
Yeah. Thanks.
Right. So essentially it is taking n cube log n, but from the question, what I can see is we can bring it down to n cube only by using counting sort. So if you see the number, so matrix of I and j is limited to 100. So for the each diagonal, we can use the counting sort, which can be done in log, n O of n time. So instead of n cube log n, we can bring it down to n cube only. Just considering your approach and just optimizing the sorting part.
Okay. Anyways, thanks. I'll post it on the platform. You guys may try it.
Sure.
Like I got an error I didn't get a TLE error. I got a test case error.
Yeah, you can post it out. Maybe we can try it out, and if we can see where it's
Okay.
because from the approach, it seems like you are on the right track, but maybe there's some nuance, or maybe the test case is not correct.
I don't know because there were people scoring full points in that test contest too.
I don't know if anyone has any other ideas about the test case. Probably they can chip in.
Tanmay, can you please post the your solution or something like what you tried for that? And
Okay, I'm doing it just a sec. I've had it both the code and the test case for which it was failing and the question on the Slack platform.